Welcome back to The Explainer, everyone. I am absolutely thrilled you're tuning in today because we are going to look at exactly how to transform messy, repetitive code into elegant, highly efficient architecture. Today, we're mastering two of Python's most foundational and honestly most powerful tools, functions and strings. If you've ever felt like your code was getting way too long, a nightmare to read, or just unnecessarily complicated, the concepts we're going over right now are going to completely change the way you program.
Okay, let's dive right into this. Today's roadmap is going to take us on a journey from building custom tools all the way to mastering the raw day-to-day process. We're starting with unleashing Python functions, exploring returns, scope, and lambdas, and then scaling things up with modules and packages. After that, we'll pivot to the data side of things, diving into the anatomy of strings, manipulating that data, and finally unlocking Python's hidden power with built-in string methods.
All right, Section 1. Unleashing Python Functions, the ultimate structural solution.
So, what exactly is a function? Well, at its core, it's really just a block of organized, reusable code. It's built to do one single specific, well-defined task. Think of it like this. Instead of writing a massive, chaotic wall of text, you're essentially building specialized tools. But why do we actually need them? Well, functions solve the absolute deepest pain points of messy programming. The biggest win, for sure, is code reusability. Let's say you need to perform the same task several times. Instead of typing the exact same code again and again, you just write it once inside a function and then call it wherever you need it. It also brings this incredible modularity, letting you break a complex program down into tiny, manageable tasks. And because your code is in these bite-sized chunks, error detection becomes literally a breeze. If a bug pops up, you know exactly which isolated block is causing the trouble. It gives you incredible flexibility to just effortlessly perform tasks in n different places.
So, how do we actually build one of these? A function definition boils down to two main parts, a header and a body. The header is what identifies the function to the computer, and it absolutely must start with that crucial keyword, def. That def keyword is then followed by whatever custom name you choose and a set of parentheses. Then, right after the header, you have the body, which contains the actual executable code block for that specific task.
When looking at an authentic function structure in action, you'll notice the header, say def fun, sitting right at the top. Inside the body, carefully indented, there might be a for loop designed to print hello world 4 times. Below all of that, you simply type fun to call or invoke the function. And the cool thing is, when a function is invoked, the program control essentially jumps right into that called function, executes those statements, and then passes control right back. It's clean, it's readable, and it just works perfectly.
Moving right along to Section 2, returns, scope, and lambdas, controlling data flow.
Now that we have our neat little function factories built, we have to understand how to control the data flowing in and out of them. And this brings us to variable scope and lifetime, which, honestly, is where a ton of common coding errors happen. Think of scope as the exact part of the program where a variable is actually allowed to exist and be accessed. We basically have two types here. Global variables are defined out in the main body of the program file, meaning they're accessible anywhere, throughout the entire file, by any function. Local variables, on the flip side, are defined strictly within a specific function. They are completely local to it. They can only be accessed from the moment they're defined until the end of that specific code block. Once the function wraps up, that local variable is just gone.
So the crucial point here is, how do we get data out of that local scope? Well, we do that using the return statement. The syntax is super simple. It's just the word return, followed by an optional expression. But it does two absolutely critical things. It returns a resultant value back to whoever called the function, and, this is the real key, it instantly ends and exits the function. Boom. The moment you hit a return statement, you jump right back out to the caller.
But wait, what if you just need a really quick throwaway function for a split second? You don't want to go through the whole hassle of formally defining it with the def keyword, right? Well, that is exactly where lambda functions, also known as anonymous functions, come in. You create them using the lambda keyword instead of def. The syntax is just lambda, arguments, colon, expression. And it's actually pretty fascinating because this feature was added to Python due to massive demand from Lisp programmers who are super used to this kind of rapid, inline, functional programming.
Let's keep the momentum going. Section 3, modules and packages, scaling your code.
Okay, so we've got these fantastic reusable functions, but how do we scale them up across massive, complex applications that are spread across a bunch of different files? We do it by scaling up with modules.
In the Python world, every single .py file you write is essentially a module, making your entire program incredibly reusable. If you write a brilliant function in one file, you can just pop into another file and access it using an import statement. One module can hold dozens of functions or classes, and when your project gets even bigger, you start grouping those modules into packages. Packages are basically collections of modules structured together exactly like a directory on your computer, giving your code a deeply structured enterprise-level architecture.
All right, Section 4. The anatomy of strings are raw material.
We've nailed down our logic tools, so let's shift gears to the raw material itself. At a macro level, a Python string is a sequence data type made up of 0 or more characters. Now, sequence just means it's a collection of elements of the exact same type. Every single space, comma, letter or symbol inside your quotes counts as a character, and Python assigns a unique code to every single one. You can declare them using either single or double quotes, and the whole thing is handled seamlessly by Python's built-in str class.
Now, if there is one fundamental rule you take away from this, it's this quote right here. Strings are immutable, meaning we absolutely cannot change existing strings. This is a massive, game-changing concept. If you have a string variable and you try to assign a new character to an existing position within it, Python will straight up throw an error complaining that string objects don't support assignment. If you want changes, there's no way around it. You literally have to extract what you need and create a brand new string.
Now, what's really interesting here is how we actually access those immutable characters using an index. Say we're looking at the word Python. You've got your standard forward index, right? Starting at 0 for P, 1 for Y, and so on. But Python brilliantly gives us a backward index as well. Notice how the last letter N can be indexed at -1, O at -2, and so on moving backwards. This completely revolutionizes how we access data, because it lets us instantly grab the end of a string without even needing to know how long the string actually is.
Which brings us to Section 5, manipulating string data, slicing and formatting.
Let's start moving from just looking at static strings to actively slicing them apart and pasting them back together. When we want to extract pieces of a string to make substrings, we use an operation cleverly called slicing. The syntax is a colon inside brackets, taking an integer value on either side, a starting index and a finishing index. It just yanks out exactly what falls between those two boundaries. We can also glue two separate strings together using concatenation with the plus operator. If we want to tack something onto the end of an existing string, we use appending with the plus equals operator. And honestly, it's pretty amazing that if you want to repeat a string a certain number of times, you can literally just multiply it using the asterisk operator. We also have absolute control over string formatting. By using the % operator as a formal specifier, we can dynamically inject completely different data types right into a text output. Using %d or %i drops a signed integer directly into your sentence. %s injects another string, and %f lets you cleanly format floating point decimals. It's essentially a way to build completely dynamic, data-driven text on the fly. Let's move to Section 6 and see how this all builds up. Built-in string methods. Python's hidden power.
Python is incredibly robust, right? So naturally, it comes preloaded with functions built specifically for string manipulation. And these save you from writing clunky manual loops. For instance, .capitalize instantly bumps the first letter of a string to uppercase. The .count method will scan a statement and return the exact number of times a particular substring shows up. And if you need to know exactly where it is, .find returns the precise index position of the first occurrence. Plus, .center will beautifully return a string centered and padded with whatever characters you want to whatever width you specify.
Think of these Boolean testing methods as your instant diagnostic tools for data. Methods like .isLower and .isUpper are going to return a quick true or false value based entirely on the case of your characters. Functions like .isDecimal and .isDigit act as bouncers, instantly verifying if your string contains only numbers. And then you have perhaps the most crucial built-in function of the entire bunch, len, which immediately spits out the total length or number of characters in your string.
Now, when we really need to analyze a string character by character, we have to iterate over it. And you basically have two ways to tackle this. The for loop is just wonderfully simple. Writing for char in message will automatically walk through every single character in the sequence, which is perfect if you want to print them out vertically, for instance. Contrast that with a while loop, which feels a bit more manual. You have to explicitly define an index variable at 0, write a condition to loop while that index is less than the length of the message, and then manually update that index every single time. So the for loop gives you this incredibly clean, automatic approach compared to manual index control.
And this brilliantly illustrates the sheer power of Python's ecosystem, the string module itself. Python literally has a built-in module entirely dedicated to constants, utility functions, and classes for manipulating strings. When you import the string module, calling string.ASCII letters or string.digits will hand you the entire alphabet and all numerical digits instantly. You don't have to manually sit there and type out A, B, C, D, E, F, G. The module has it prepped, packaged, and waiting for you.
Wow, okay, we have covered a tremendous amount of ground today. You've seen exactly how defining custom functions and managing local variables brings this amazing, modular, reusable architecture straight into your logic. You've also learned how to precisely slice, format, and iterate through the immutable structure of strings using Python's awesome built-in methods. So now that you've mastered these fundamental building blocks, the real question is, what complex Python architecture will you build next? Take these tools, fire up your code editor, and go create something amazing. Thanks for hanging out with me on this explainer, and I will see you next time.